The World Health Organization estimates that depression affects more than 350 million people globally, with teenagers emerging as one of the most vulnerable populations. But the traditional clinical model faces a significant blind spot. 70 researchers have discovered that machine learning algorithms can now analyze this unstructured social media text to predict depression with a surprising degree of accuracy. This meta-analysis of 36 different studies shows a significant correlation. Looking at the fixed and random effects, we see an overall effect size of R equals 0.630, proving that the digital signals are consistent and measurable. While your electronic health records are shielded by strict federal laws, these detailed algorithmic psychological profiles currently exist on the open web. This has left us with a paradox. We have built a precise, life-saving diagnostic tool that sits inside a wide, unregulated cybersecurity loophole. To understand how a teen is diagnosed digitally, we have to look at the models themselves. Researchers often choose between shallow learning for speed or complex deep neural networks to understand the context of a conversation. The algorithm starts by scraping demographic features like age and location, which researchers have identified as the strongest baseline predictor for a depression diagnosis. But those same demographic markers are exactly what commercial data brokers use to construct shadow profiles, which are then sold for targeted and sometimes predatory advertising. The AI looks beyond simple keywords, scanning instead for structural markers like first-person singular pronouns and phrases associated with rumination. By tracking these subtle linguistic shifts, the algorithm can map an underlying emotional state, even if the teenager never explicitly says they are feeling sad or depressed. The model isn't just reading the message, it is decoding the underlying style, turning casual conversation into a searchable map of psychological vulnerability. The third feature focuses on social media activity. The algorithm specifically flags a sharp drop in the total volume of daily posts as a potential digital warning sign. It calculates reciprocity, the rate at which a user likes or comments on their friend's content. A sudden lack of interaction acts as a digital proxy for real-world social withdrawal. Finally, temporal data tracks the exact timing of a user's digital activity to uncover the hidden symptoms of severe insomnia. Temporal data maps out a precise schedule of vulnerability. If this information reaches bad actors or predatory algorithms, they can target their engagement for the middle of the night, when a minor is most likely to be alone and emotionally unstable. When these four features, demographics, language, activity, and time, converge, they create a near-perfect digital mirror of a teen's mental health, visible to anyone watching the data stream. The potential here is life-changing. These tools could identify high-risk teenagers and provide them with support and resources long before they hit a crisis point. However, the study shows that the type of platform, whether it's a public network like Twitter or a private one like Facebook, changes the way these algorithms calculate depression risk. This leads to a structural legal loophole. Because this data is derived from social media platforms rather than clinicians, it isn't legally classified or protected as medical records. This allows hackers, unscrupulous advertisers, or extremist groups to legally purchase lists of teenagers who have been digitally diagnosed as severely depressed. As machine learning is integrated into our mental health care, we must treat our digital footprints with the same security we demand for our medical records. Otherwise, the diagnosis becomes its own unique danger.